Okay, this is a review of laws of exponents, and it's part 1 by James Lang. In this part, we're just going to review some of the basic laws of exponents and do a couple of examples of using those laws. And then in part 2, we'll do more examples where we're trying to use the laws of exponents in writing expressions in a particular form. But for part 1, let's just review the laws and include negative and fractional exponents and look at an example or two. So, first of all, you've all seen the laws of exponents in algebra probably 2 or 3 times, and you must feel a little uncertain about it, or you probably wouldn't be watching this video. So let's take a look at the laws of exponents. Now, first, I've written down the left-hand side of the laws that I'm going to talk about here. And the first one is x to the n multiplied by x to the m. And then the next one is x to the n raised to the m power. Now, I think probably from what I get what I hear students tell me is, well, okay, I know you got to add or you multiply, and usually there's some disagreement. When do you add, do you multiply? And so before I write these down, let me show you something that you can always figure out whether you add or multiply. Just take an example like x squared times x cubed. And now the question, do we add or multiply? Well, if you think about x squared means x multiplied by x. X cubed means x multiplied by x multiplied by x. And so what we have are 5 factors of x, which is just this x to the 5th. So what did we have to do to the exponents? Well, we had to add them. 3 plus 2. And so over here, when you have a power of x multiplied by another power of x, notice the base is the same, then it'll be x to the n plus m. In other words, you add the exponents. Now, you could do the same thing if you wasn't sure about the second one. You could say x squared raised to the 3rd power. Well, anytime you raise something to the 3rd power, that means you write 3 factors of it and multiply them together. And so you have x squared times x squared, which is x to the 4th, and x to the 4th then times x squared, which would be x to the 6th, and that would be multiplying the original exponents, 2 times 3. So when you raise a power to a power, you have x to the product of the exponents. You multiply the exponents. So x to the n raised to the m power is x to the nm. Now, those are the two that students tend to get confused, and hopefully if you think about writing it out as I did over to the right here for small exponents and see what has to be the case. And then the next one, when you divide powers, instead of adding the exponents, you have to subtract them. And so this rule is you take the x to the n divided by x to the m will be x to the m n minus m. So you subtract the exponent in the denominator from the exponent in the numerator. That's 3 of the laws. The other one's a little bit different in that you don't have the same base. You have an x and a y base, and we're going to raise that to the n power. And the law for that is that you can raise x to the n power and you multiply by y to the n power. And the reason that works, if you just write it out for a small value of n, you could see that if you have xy cubed, for example, you could write that as xy times xy times xy, and because when you multiply things you're able to order them and rearrange them in any order you'd like, I'll make it x times x times x, and then times y times y times y, and that gives me x cubed y cubed. And so that's what the last law here is saying. So I'll number these in case I need to refer to them. 1, 2, 3, 4. Of course, there's no importance in how you order them. Now, the next thing we want to look at is what do you do about something like x to the 0 power? What does that mean? So that's a question. What does it mean? And you may remember the answer, and that'll be good. In case you don't remember the answer, I'm going to show you a way to think about that. Well, first of all, you might say, well, I just won't write x to the 0. Well, the problem is you may get forced into it. For example, if you wrote x squared over x squared, and that was what you started with, and you applied the laws of exponents. We always want our laws of exponents to work. So according to rule number 3 above, this would be x to the 2 minus 2, which would be x to the 0. So sometimes you get forced into an x to the 0. You don't start out by saying, oh, I'll just write down 0 factors of x. It just comes up in the process of using the laws of exponents. So what do you do when it does come up? Well, the answer is right here in front of you. X to the 0 is what we got on the right-hand side, but on the left-hand side we started off with x squared divided by x squared. Well, that's like 25 divided by 25, or 49 divided by 49, or 13 divided by 13. It's a number divided by itself, and that always gives you 1. So if you want the laws of exponents, 1 through 4, to apply, there's no choice but x to the 0 has to be 1. Now, this is true for all numbers, all values of x, except if x is 0. Because then you couldn't be dividing by 0 squared, because you've learned or you've been told, programmed, that you cannot divide by 0. And so, this is true as long as x is not equal to 0. X can be 13 or 1.729 or any number except 0. X to the 0 would give you 1 for any number except when x is 0. Now, so that's x to the 0. You might say, well, okay, I don't think I would have run into a problem with that. It's just 1. And so, but the reason I wanted to remind you of that is, so what if you have x to the negative 2? And you want to, what does that mean? Okay, well, again, you may remember what they told you from algebra, but what does it mean, and why does it mean what they said in algebra? Well, the way to think about that is that we always want our laws of exponents to work. So if we want law number 1 to work, then if we multiplied x to the negative 2 by x to the positive 2, according to the first rule up there of exponents, we would have to add the exponents. And so we'd have negative 2 added to positive 2, and so we would have x to the 0 power. But we just said x to the 0 power has to be 1. So that tells us that x to the negative 2 multiplied by x to the 2 has to be 1. Well, okay, so what? Well, that means that x to the negative 2 has to be 1 divided by x squared. Because we could divide both sides of the equation by x squared, and we just have x to the negative 2 on the left side, and we'd have 1 divided by x squared on the right side. So x to the negative 2 has to be 1 over x squared if the laws of exponents are going to work. So that means, in general, x to the negative n is just 1 divided by x to the n. And again, the reason for that is if we multiplied through by x to the n, we'd get x to the 0 when we use law number 1, and x to the 0 is 1, so it has to be this way. So I'll call this rule number 5 in our laws of exponents. Now, let's see, we have one more situation what if we have a fractional exponent? For example, suppose we had x to the 1/2 power. What does that mean? Well, it doesn't make any sense to say you'll take half of a factor of x and do something with it. So what does it mean? Well, x to the 1/2 power. The thing to realize is we want our laws to work, and so if we raise that to the 2 power, that's going to give me x to the 1/2 times 2, by law number 2, law of exponents number 2. So that would be x to the 1 power. But you do remember, I hope, that x to the 1 power is just x, same as x. And so that means that x to the 1/2 power, when it's squared, will give us x. Now think about that for a minute. X to the 1/2 power, and we square it and we get x. So if you think about a number whose square gives me x, that's what x to the 1/2 is. It's a number whose square is x. And that's called the square root. So x to the 1/2 is a number whose square is x. So x to the 1/2 is a square root of x. So an exponent of 1/2 would be a square root. Now we would use exactly the same reasoning, and we could say that x to the 1/3 is a cube root of x. Same reasoning. Now, usually when you see square root, you see the symbol, square root symbol, and see it written like this. And a cube root is written the same way with a radical, except you put a 3 in the index, they call it. And so x to the 1/3 means a cube root. Now, using these same reasoning, you would say that x to the 1/5 is, and now the pause is for you to fill in the blanks right ahead of me. That would be the 5th root of x. Okay, so that tells us how to interpret a fractional exponent, as long as the fraction is 1 divided by something. So what if we had x to the 2/3? So what would that have to mean? Well, if you think about it, 2/3 could be written as 1/3 times 2. You have to remember 1/3 times 2 would be multiplying fractions, where the 2 is 2 over 1. And so 1/3 times 2. But that means that when we get x to the 2/3, it could have come from taking x to the 1/3 and then raising that to the 2 power, because law of exponents number 2 up at the top of the page says that when you raise a power to a power, you multiply the exponents. So x to the 2/3 has to be the same as x to the 1/3 squared. Or another way of saying it, you could have said it was x to the 2nd power, x squared, raised to the 1/3. Either way. So the way you think about the fractional exponent then is the denominator of the fraction is telling you what root you're going to take, and the numerator of the fraction, which in this case is 2, is telling you what power you're going to take. So a fractional exponent. So to try this out with another example, what would x to the 4/5 mean? X to the 4/5 would be the 5th root of x raised to the 4th power. Or, if you prefer, you could say it's the 5th root of x to the 4th power. Either way. Okay. Now, let's do a couple more examples and finish up part 1. Okay, we're going to do an example which says to simplify the cube root of x divided by x squared and write the answer using positive exponents only. So, to simplify this, we see that we're dividing two powers of x, x cube root of x and x squared, and so we first write it as exponents, so we write x to the 1/3 for the cube root of x. X squared, we don't have to rewrite that in any way, it's already an exponent. So now, whenever you have x to the 1/3 divided by x squared, we apply our rule of exponents. When you divide powers, you subtract the exponents, and so we would have x to the 1/3 take away 2. Now, we should simplify that exponent. So that would be, if you remember, you have to have a common denominator, which would be 3, and so negative, or 2, can be written as 6 over 3. And so this is x to the 1/3 minus 6/3, and that would be x to the negative 5/3. So x to the negative 5/3, and so this is simplified compared to what we started with because we have just one power of x and we just have an exponent of negative 5/3. However, there's one other thing we're supposed to do. It says leave the answer with positive exponents only. So we can't stop here because our exponent is negative on x. And so then we have to take one more step and remember the law of exponents. Whenever you have a negative exponent, that's 1 over x with the positive of that exponent. So negative 5/3 you write as 5/3 when you write it in the denominator. So x to the negative 5/3 is 1 divided by x to the 5/3. Okay, now a second example. I'm going to start with the square root of x multiplied by 2x plus x cubed, and I want to write this as a sum of powers of x. Now, as you go through calculus, you'll find out that if you can write something as a sum of powers, you can work with it a lot more easily than you can if it's a product or a quotient like this is. So we want to write this as a sum of powers of x, and we want to simplify the exponents as much as possible. Simplify the exponents. So, now, the first thing you need to do is to recognize that we have something in the form of the distributive rule here, where we have something in front, a, multiplied by two things that are added, b plus c. So the a is the square root of x, and the b is 2x, and the c is x cubed. So it's a distributive situation, so we will apply the distributive rule, and ab plus ac. So in other words, we'll distribute up here, and we'll have 2 times the square root of x times x plus the square root of x times x cubed. Now, at this point, we can apply the rules of exponents. When you have square root of x multiplied by x, that's the same as x to the 1/2 multiplied by x to the 1. And so that will be the same as x to the 1/2 plus 1. Again, 1 is 2/2, so 1/2 plus 2/2 is 3/2. And then we move to the second term, and we have x, the square root of x is x to the 1/2, multiplied by x to the 3rd. Now remember, when we multiply powers, we add the exponents. And so we would add 1/2 and 3. 3 is 6/2, and 6/2 plus one more half would be 7/2. So x to the 7/2 power. Now, we have a sum of powers of x. 2 times x to the 3/2 plus 7 plus 1 times x to the 7 halves, and so that is simplified as much as we can. So that's the end of the second example, and this is the end of part 1. In part 2, we'll look at more expressions similar to the last one with different combinations of addition and division and multiplication. Okay, hope this helped for this part.